So welcome to this meetup about attacking your tech debt with radical quality using Dantotsu. It's a pleasure to have Fabrice with us and having all of you with us on this lunchtime today. Fabrice, do you want to tell us a bit more about you before we start?
Yes, I can. So my name is Fabrice. I'm the co-founder of Theodo. I'm also the co-author of a book, the LeanTech Manifesto, that came out this year, and which captures our learnings across the last 12 years, growing Theodo from 10 to 700 people and trying to maintain agility at scale using both a lot of expertise from Lean and also like trying to use technology as much as possible.
And I'm Philippe. Thank you, Fabrice. I'm Philippe. I'm the host of this meetup. And today I'm going to be very, very quiet and listening to Fabrice because that's a theme I absolutely love. Continuous improvement and Kaizen and all the techniques that allow basically the team to take ownership as well as making organization improve themselves all the time. So very much looking forward to that. I will be monitoring the chat, logging the questions. So if you have questions, we make sometimes some top stop during the presentation, or sometimes we go all the way to the end and ask them. So if you put some of them in the chat, and I will track them, and then we'll discuss those with Fabrice at the end. Just a quick positioning. We've done two sessions. The first one was introduction to the LeanTech series and the LeanTech manifesto, with a key element around how to actually scale without really scaling, and the modularity that there is in software and bringing that into organization, which was really fascinating. Then we talked about the alignment to value and the aspects of taking value as the beacon to align to, and how we could use Worldly Maps for that. Today, we're talking about quality and excellence, and often organizations don't do such a great job, and it means firefighting becomes the norm. And unless the quality is in check, then actually it's very little point in having a strategy or having much more than that, because you're always firefighting. So it's going to be fascinating to hear from Fabrice, not just what's in the book, but actually what Fabrice organizes on the day-to-day in practice. And this is really where I think it makes a huge difference when we're able to implement the theory in the day-to-day. So I'm looking forward to hear from Fabrice on that. And we'll cover on the 10th of January. It's the last meetup in this series where we look at what make that LeanTech leader. So how, yourselves hearing from those different perspectives, how can you become the LeanTech leaders of the change, of the continuous improvement, of organization that improve themselves all the time? So without further ado, over to you, Fabrice. And
Thank you.
I'm going to be just in the background. You can message me if you need any support. I'm going to stop my share now. Over to you, Fabrice. Thank you.
All right. Let me do this. And Zoom, share screen. Here we are. So yes, I want to share with you our learnings of over the last, I'd say, 3 years around attacking quality in a very different way, and inspired by a book. So I'll give you more about that in the slides. The slides are, we'll share really our learnings, but I think the part that interests most of you when I look at the chat is really tech debt on legacy projects. So we'll probably have to spend some time discussing this between us. All right, let's start with the quality at scale dilemma. So the idea is, we're eaten by technology. Software is coming everywhere. And it started with digital transformation and these amazing startups like Netflix, Amazon, or Airbnb that completely disrupted the industry. I found it quite interesting to like focus on Europe, where there's been so much investment, not in last year, but over the last 5 years on financing companies that are trying to disrupt their industry using software. And that translates into IT spending going up even in harder times such as this year. We can see that the IT spending is still going up, which is a good news for everyone working in tech, probably. And I like the metaphor of to the moon that the crypto community loves. But that is all amazing until defects happen in critical systems. This is, for example, the explosion of an Ariane rocket that cost them about 500 million. So yeah, quite annoying. And this was caused actually by the line I put in yellow, which is the wrong casting of a variable. And I mean, of course, then you can do the whole root cause analysis of what happened. But yes, the reality is one small bug, 500 million. So the more software is eating the world, the more our quality will be critical, and a defect might cost a lot of money. What I found very interesting is then once you've acknowledged that quality will become more and more critical over the next 10 or 20 years. What do we know about quality? So typically in the aerospace industry, they've had this kind of problem for a long time. And so one number I found amazing, when they added the GPS piece of code for the shuttle navigation, that was 6,000 lines of code. And their quality process meant that they had to write 2,500 pages of specs before that. So interesting. Let me reduce myself. So interesting in terms of kind of orders of magnitude. That means for the whole program, they write about 40,000 pages of quality documentation. I mean, and I thought it would be interesting to visualize what 40,000 pages look like. So this is a photo of Margaret Hamilton. She's just chosen here to represent a human being, and she was the first software engineer working on the Apollo guidance system that brought the men to the moon. And when you look at what is next to her, that's 11,000 pages. So 40,000 pages actually looks like that. So that's a lot. And so we're really, and so this is typically something that in our digital world is completely unimaginable. We come from a world. This is a screenshot from the social network at the really beginning when Mark Zuckerberg and the first software engineers of Facebook have these kind of challenges where they drink shots and code at the same time. So this, Facebook was famous for making the sentence move fast and break things popular. And just to give you a bit of numbers, what is kind of observed, at least on the shuttle software team, is about one defect for every 400,000 lines of code. It's a bit difficult to have numbers, but one number that comes back often is about 10 to 50 defects per 1,000 lines of code. So that means about 5,000 defects per 400,000. So you've got a 5,000 difference between the shuttle software team and let's say a normal industry average. And that brings us in this complicated dilemma where we have something that is definitely not scalable. You can't convince devs to write that many quality specifications, but then also generating 5,000 defects for similar programs is just not acceptable. So what is the third way? And we ended up in this interesting situation where we were on this really large project, had implemented amazing DevOps best practices, We were deploying to production new features 40 times a day. So really, I don't think you can do much better. But the scale of the project meant that we still had like defects going up. And so Woody, who was part of that project, was looking for something new, and he found this amazing book by Sadao Nomura called The Toyota Way of Dantotsu Radical Quality Improvement, which is quite amazing. It's the story of it's a story of Sadao Nomura, a leader at Toyota that made radical quality improvements in forklift factories. And so this is quite exciting. Why? Because Toyota is a company globally known for its obsession with quality. So having such a detailed documentation of how they achieved some amazing results would be definitely fascinating. And for those of you who come to this meetup, but I'm completely convinced that Toyota is amazing, I recommend this amazing Top Gear series of episodes called How to Kill a Toyota. And then they spend basically 3 episodes trying to kill a Toyota. So they ram it and put it in the sea near Bristol, I think. And yeah, that's near Bristol. Trying to drown the car, and then they end up actually putting it on a council estate that's about to be exploded. And so you can see the car falling from a 10-story block of flats and being removed from all the remains, and actually still, I'm sorry I spoiled the conclusion of this series, but basically at the end the Toyota is still functioning. So you can see how this quality culture at Toyota is not just a legend. There's actually real consequences, which is that some of their cars are incredibly resilient to any crazy things that Jeremy Clarkson can imagine. So in this case, he's trying to he's tasked with improving quality in forklift factories, which already had a very good quality records, but not up to the standards that the Toyota top management wanted. And he's been able to reduce defects by 98% in some of the factories, which is quite crazy considering it was already quite good. It didn't, and often when we think about Toyota, we think, yeah, but maybe it's because they're Japanese, so they're different than us. One of the examples is in a US company they had acquired where they did a 99.7% quality improvement. So that's quite crazy, and it got them an award for outstanding quality. So you read the book and you're like, okay, what's the secret? It starts in a very interesting way. I mean, sorry, there's a bit too much text on that slide, but it starts by Sadao Nomura basically writing an A3, so a strategy on basically 2 pages describing what to do. And so when I read that, I was like, wow, it's as easy as writing 2 pages. So no, of course, the outcome was that when he came back 3 months later, nothing had changed. So what did he do? He wrote another A3 and was more empathic about the need to do things. And then on the 3rd visit, still hadn't changed either. So that kind of reassured me, because my experience as a leader in an organization is that if you write a strategy and give it to people and tell them to do that, and things will improve, things don't improve. So yeah, that was at least reassuring to me that that was not enough. So anyway, Sadao Nomura is very frustrated. He's not used to apparently things not working out this way. I think as a context, he had been heavily involved in his previous experience. And it was like the first time that he was actually trying to lead from further away. Like there were like 7 factories involved. So for him, it was very difficult. Like he didn't know what to do. Anyway, so he finally decides to change his strategy, and so he does what he calls the Dantotsu quality activity. Dantotsu is a Japanese word for unparalleled or radical or over the top. And it's really the beginning of him going into kind of crazy mode with the support of Toyota headquarters. So concretely speaking, a lot of visual management, key point number 1. So he puts these kind of graphs everywhere on the walls, across across the teams. They can actually like start counting defects and categorize them, etc. Second key point, which we found fascinating when we started making the parallels with our world of software, is he categorizes defects not by a priority as we tend to do, but by stages of outflow. Because the idea is that no defects should reach the final customer. And so the question is, how can I measure the fact that I'm detecting them earlier and earlier? Another categorization that I found very interesting is they classify by where the defect originated, because of course the interesting thing is then you can actually assign that defect to that team and ask them to analyze why that defect happened. So very important to actually quickly identify where it came from. And then what I found fascinating is the huge involvement of the team leader in that quality process. So basically there's 8 steps that the team leader has to go through for every defect, from checking the defect, checking whether it's impacted already other places, investigating the defect's cause, redoing the analysis, implementing the countermeasures, sharing the learnings the next day. So I'm kind of spoiling the next slide. And then improving the standards and the documentation, training material, etc., to make sure that the learnings actually get deployed across the organization, training the workers using that new training material, and then doing some accountability, checking that things are working as expected. And what is of course crazy is that it's all done in 24 hours. So all the the analysis and the countermeasure is happening the same day, and basically sharing the information, documenting it, training and checking people have learned, it happens the next day. So very, very intense. When I read that, I thought it was very funny, because when I was comparing to the number of backlog refinements our team leaders are going through, clearly it's a reinvention of the role of team leader, I think. And then one thing I found very interesting is the way he structures the systematic analysis of every defect. Here you see how, like a screenshot of the book, where you see all the defects and how they're analyzed. I'll go quickly through that because I do want to discuss this then later. But what I thought was very interesting, I had so many debates internally with my teams around, when you analyze a defect, should you analyze how I could have prevented it, or should you analyze how you could have detected it? In software, it's always similar. Like, I was more in the prevention camp. I tend to be frustrated when people tell me what kind of unit test I should have added, or what kind of end-to-end test, because I think, no, that's not what the fundamental learning. The fundamental learning is what is wrong in the working conditions or in the current system, and that made the thing possible. Well, Sada Nomura has an answer to that debate, and the answer is, of course, we should do both. And that's the solution to the debate. It's as interesting to analyze how we could improve the working conditions so the thing can't happen anymore, as it is to analyze how the kind of detection mechanisms you can put in place to detect earlier. Last key point, there's once you've done this like crazy intense reaction to defects at the team level, there's an investment on systems to leave no chance for defects again. So typically, he gives this very interesting examples of some consumables actually getting too old and introducing potential defects. So there's a real big A3 on how to completely change the way consumables are managed. So what is the translation of all these ideas into code? When we tried, we had first a big debate, what is a defect? And that, in itself, it can already be like a huge issue in a team. We decided to have a very broad definition, which is any unexpected behavior for the user. And so then we radically increased the visual management. So we've tried so many different things. On the left, you can see like a very old school paper version. On the right, you can actually see this weird experiment, retro experiment to make it sexy. in like it's a screen in the open space. And actually the one that is still ongoing is actually the one at the top right, which is a tool that we built that connects to all the potential feature tracking tools we have, Jira, Trello, Notion, Azure DevOps, and connects to the API and detects any tasks that are considered that are labeled bugs, and is able to then count them across teams. We standardized our outflow classification. That was a very interesting discussion we had among all the CTOs in the group. So we ended up with actually 5 levels. A is detected by the developer themselves. B is before it reaches an internal customer. So before product owner, before QA. C is if it's detected by an internal customer, so during inspections, it could be the product owner, it could be the QA, it could be whatever, someone who's not the dev team. And then D is when it's detected in production, and E is when it's detected through a user complaint. And here we can see a small difference with, of course, physical objects like cars. You can't really detect a defect in a car once it's sold unless the customer complains. We have that difference in digital, that we can actually monitor the production environment and detect some, hopefully, things before users actually detect them. And of course, the very interesting thing about this outflow classification is then we have this very healthy target of saying, okay, if we count A, B, C, D, E, the goal is not to reduce defects in general. The goal is to like bring the numbers way to the left, which is now popular as a shift left approach. One interesting thing was to clarify the defects can originate from different teams, and it's particularly important to mention that because if we say a defect is anything that is unexpected behavior, then you have really complicated conversations, time to introduce a nice meme. But we had this issue where one of the defects reported was that one of the buttons was using the word login. And we're like, yeah, what's the problem? Is the login button? So why is it a defect that it says login? And the problem is it was a French product, and it was used by people who didn't speak English, and they didn't know what login meant. And so this can create, it's quite create actually tensions, because the dev team is like, this is not my problem. This is not coding. This has nothing to do with me. If people don't know how to speak English, please don't add me a bug ticket in my in my Notion. But here we'll be able to say, no, it is a defect, and you're right, it's not a dev defect, it's a content defect. So we're gonna like put it in the Trello, but for the content team. All right. So we experimented with tech leads analyzing a bug fix a day. So that's been very interesting in terms of journey, because I think, it's already a big step forward to have a post-mortem kind of culture where you analyze issues. And the big next step is to actually analyze issues really quickly. People tend to, in my experience, probably in our culture, people are very happy analyzing defects, but they are very happy to spend 3 weeks doing complete archaeology of who introduced the wrong wording in the specifications 18 months ago, and who then got it wrong when they coded it like 12 months ago, and how come it was not initially an issue but then became an issue 3 months ago when we merged this and this together, whatever. And the problem is, if that's what you do, is if you spend like basically 3 weeks and lead time and probably 5 hours in touch time trying to analyze the defects, it will be very difficult to make it systematic enough. So the idea was to actually train people into coming up with interesting insights, but in half an hour. And that meant standardizing the template to fill in, and really then training people into how can we really quickly get to the level of insight that is interesting, but doesn't waste you like 3 weeks of time. And as you can see in the template, we've got the main learning on how the defect could have been prevented, and we have the main learning on how the defect could have been detected earlier. So we put the tech lead at the heart of quality again. So not as crazy intense as in the Sadanoma's book, but the idea was to say to the tech lead, well, you need to have time to fix the defects. You need to have time to analyze them. And you need to have time to, check if that defect is somewhere else, and implement the countermeasures and share the learnings the next day with the team, and then decide whether, if you have ideas of how you could refactor stuff, then potentially add them to the next sprint. So that was kind of what we suggested. I would not say that's exactly what happened on the ground. Probably because in a team of engineers, everybody's able to analyze. And so there's no, the clear-cut separation between the tech lead has time to do that. It's not exactly what happened. So example of countermeasures, create linter rules, add tests, improve test fixtures, also rewrite parts of the system, improve the naming, improve the domain modeling, and then create or improve training material, and or just simply train people better on identified skill gaps. So we even experimented with the craziest thing of all, which is defects. So defects done, detected by the developer creating them. So what does that mean? So the idea of the experiment, which I thought was like quite impressive, so the dev in the team would have the discipline of when they start a feature to add a line in the Notion page, and then they were allowed one test in the browser, one test in the phone simulator. And if it didn't work as expected at that test, they considered they had an A defect. And so the opposite of A defect, they call that RTFT, for right the first time. And so they would track it and gamify it and say, okay, I was able to write code and it worked the first time I actually checked the output. Or I know I had to modify 2-3 things. So that's quite crazy when you think of it. It's the only but it's also the only kind of plausible interpretation we could have of what A could mean in our industry. So one of my first reactions was to say, one refresh. I mean, how crazy! I've never coded like that. I basically code while refreshing, especially in web or mobile. You basically code blindly and check if it's working in the browser. But the idea behind this initiative was that, but that's actually very probably complete waste, because you're spending your time like switching context between the code and the output. And it's probably be healthy to try not to do that. And indeed, it's done, I think, some very interesting things. At first, the team that first experimented with it found it very funny and gamified it, and it brought some fun to their, I'd say, daily work. And they all reported that it made them think a lot more before coding. And some examples of stuff I would never have expected, but when you do web development, CSS seems like a bit like painting, like you try and. But actually, what the team started doing is train themselves on CSS theory, and then actually calculate using pen and paper the positioning of stuff, and to do it the first time. And basically, the knowledge of CSS went up by a lot, and the outcome was, of course, that it worked a lot more often from the first time. And another thing, incredible learning about that, is it basically made TDD the only way that made sense to work. So it was not TDD because it was imposed by leadership. It was TDD because I wanted to win the game of, code working the first time. So that was very, very cool as an experiment. So anyway, generic learnings. We're still struggling to connect the efforts better with the big picture, at the team level. So we've had different experiments around that, but nothing very convincing. On large ongoing projects where you have a lot of tech debt, it works, but it takes months. And the very interesting metric is that we found on average that the introduction of the defect, I don't know why that was kind of the average, but it seemed to be on the particular big projects that we were working on about 9 months. So you can see that if what you're learning, what you're detecting and analyzing is 9 months old, then all the efforts you're doing now will probably only work in 9 months, at least. But okay, some interesting results. First, the project that did this crazy RTFT challenge. So that's a greenfield project, so it's not tech debt. It's less than 6,000 lines of code, 120 days of work from engineers, and the outcome was 2 defects in production, 2 defects in inspection. So if you compare that to the kind of numbers I gave at the beginning, we're talking about 0.3 defects per 1,000 lines of code. So we're approximately 10 times better than industry average. That's really, really cool. And done in a gamified way, where the team actually really enjoyed themselves doing it. Another example, because a lot of you are asking about tech debts and balancing rework and analysis, etc. So this is typically the first project I was talking about. So teams are deploying 40 times a day. So small increments, etc. We're doing all the DevOps best practices, but the scale of the project and its complexity means that defects are still going up, despite all doing small increments. So what did they do? So they introduced a lot of visual management, so quite a big emphasis from management that it's important. And to talk about time balancing. I'm missing a thing, but basically the bottom of the calendar should be highlighted in red. So typically teams that were willing to do that put a meeting at 6 p.m. in their calendar. So every day at 6 p.m. they would spend half an hour analyzing 1 defect. So there was 1 defect a day. And we're not necessarily in production, by the way, because again, we're counting every defect from A, B, C, D, E. Yeah, so Thibaut, one of the leaders that did that for a few months, for long enough, basically shared his learnings in a talk, but I realized it's a talk in French. Anyway, the outcome is defects in production did go down, and in a quite impressive way. We're talking about going from 70 a quarter to like 10 a quarter, so 3 months. So yeah, it's not 0, but it's still 7 times better. And the investment, the time investment was basically half an hour a day. The energy investment is probably more, but yeah, it's quite interesting to see that. Anyway, so as a conclusion, and of course this is still all work in progress, but I thought it was super interesting to see the results already of these experiments, because between the not scalable solution and not acceptable solution, we seem to have found an interesting way that is approximately 10 to 15 times better than industry average, while being actually enjoyable and doable by millennials. And so we hope that it's work in progress, so we hope we can even improve that further. Inspired by Sadao Nomura. Anyway, and this is my last plug. I talk about it in the LeanTech manifesto. I talk about a lot of other stuff. I did mention in the talk that the importance of DevOps best practices already. So yeah, I kind of assume that you're already deploying 40 times a day, but of course that's not the case in most projects. If you want to follow the journey, you can follow me on LinkedIn. I'm very happy to connect, and I'm trying to post around these topics like on a daily basis now. So anyway, thank you very much, and we've got enough time for questions, so please throw the questions at me. I'm more than willing to try to answer.
Thank you, Fabrice. Thank you. And there's quite a few questions that I noted along the way, so we may as well go through them. I have one, and since I'm the host, I may as well sort of start with that one as well. If you have questions, please raise your hands, and I will look at saying it's not audio, or if you capture it on the
Oh,
chat,
Fortune, raise a hand.
then
Hi,
then you
Fortune.
can do that. So, Fortune, since you raised your hand, you're trumping me. You'll ask the first question. Go ahead.
Thank you so much. I'm so grateful for Philippe and Fabrice. What a great presentation. I'm sorry I
Thank
came in
you.
just a bit late. Not long after your book came out, I spoke to some people at Industrial Logic, the great, XP code crafts people, about the Dantotsu method of bugs. And they said something to me that other people have asked me since. Why not just do XP from the beginning with mob programming? What's your
Um,
answer to that?
yeah, it's a good one. As I said, what I found interesting is the people that did this kind of RTFT challenge ended up doing things that looked very much like XP. I still believe XP is amazing. And I guess what I'm sharing here is ideas that are different, but with similar objectives and which end up having like overlaps. Yeah, it's interesting. Why don't we all do crazy XP? The reality is I've never managed to convince teams to do XP outside of small experiments. But I've not managed to convince teams to do RTFT outside of small experiments. I mean, it's kind of similar. So we're trying different things. We did other crazy things. Yeah, it seems like all these practices are still they require quite a lot of engagement. So yeah. So anyway, my point is, because you're kind of like, pointing at a very good thing. I think my point is the more general Dantotsu approach of systematic analysis of defects, that's much more scalable than RTFT or XP, which is, is a great tool for great team leaders, but not for everyone.
Okay, great. And what was the cost savings, dollar-wise, when you lowered the bugs, either in customer value, costs avoided, or time saved? Cash, what CEOs want to
Wow.
hear.
Yeah, it's a really good point. It's a really good point, and I feel bad not having done that exercise, but it also shows you it's not obvious. Like it's really hard to say after the fact how much you've saved when you've done good quality. You know what? Actually, I could have come up with numbers because I remember when we did the Dantotsu on the very large project, we actually made the effort of saying how much more would it cost to really accelerate some of the quality initiatives and how much we expect to save over time. So I do have that calculation somewhere. Of course, it's estimates, etc. But it would be interesting. So you remind me, I need to have it. I need to learn it.
And it's often the case in trying to justify quality with cost savings or efficiencies and measuring that. It's always a difficult case to make because you'd struggle to normalize how the quality is making you hurt. But on the other hand, when everybody is in the action trying to fix that, you see it very obviously. And that's why the Gamba was so important in Lean.
You're reminding me, like I remember, like on the very large project, one of the kind of way we created a business case was to say some of the teams are spending 80% of their time on what we call rework, and that's not okay. And so the idea was to say, okay, we need to bring from the target is 20%. And so we need to target the teams that are at 80 and put the time in to bring it to 20. And then of course we'd say it will take us that many weeks, and then we'll have a 60% basically productivity increase on all these teams. So that's how we make the calculation.
Thank you, Fabrice. I had another question for you, and we're going to go through a list as well. There's an obvious thing and something in Toyota that is very important in Jidoka. It's the hand-on cord. Have you implemented, and for everybody here, is the idea of hand-on is that you stop the work to swarm on a problem, and you create efficiencies by having the team swarming, solving the problem, so they don't go further downstream, and at the same time, you also create a culture of quality by showing that it matters when you stop the work. Have you implemented such, and it's not obvious where to implement it. It's obvious in the production chain, but in tech, it's not obvious. Have you implemented such techniques?
I mean, you remind me of all the crazy things we've tried. So one thing we tried at some point, we called it ghost programming, and it was a reference to Mario Kart. When in Mario Kart you can race against your best time. Best time is a ghost, and you race against the ghost of yourself. And so ghost programming was this interesting thing where we would say, okay, my expected time to do this is I'm blurring myself. The expected time is in small increments of 5 minutes. For this task, I think I would spend 5 minutes like changing the model, 10 minutes building a test, and then 10 minutes building the function. And then we went all the way to actually buy this hand-on lamps, connecting them in USB with the little tracker we had built. And so if you were late on your plan, the light would become red and the team leader would run to like say, okay, oh, you're later than your expected time. So, it's probably an interesting sign that you need help. So we tried that. It was incredible. The team, increased productivity by 3 times. Of course, it was too intense, so we didn't make it mandatory. So that's one answer. And the answer on the answer on Dantotsu is that really it's meant to be the defect analysis is meant to be like some kind of, it's not an instant swarming, but at least you get in, when you're looking at a defect, you're at least looking at it on a weekly basis and getting help from someone if as a dev you don't ask for help. And then we inside Theodo, we really like insist that the culture is undone. So when you're stuck, we call it tunneling. So you shouldn't be tunneling. You should be asking for help. Yeah, and then we implement Scrum in the teams. So we've got the daily. The daily is also meant to be the kind of undone where if you're not on time the next morning, well, that's a good sign that you probably need help. That you most probably need help. So I mean, I'm giving multiple answers, but the real like kind of cultural organizational level answer is yes, we insist all the time that tunneling is not okay. This is the word we use for that, and then you should hand on your team leader when you're stuck.
Cool, thank you. Taking some of the questions from the chat, I think one of them was, can Dantotsu work with small development team? And we already replied in the chat to this one. The answer is yes, and it's probably easier, I guess.
Yeah, the most extreme teams, the most extreme examples we have are teams of 3 people. The obvious correlation, I mean, it's obvious to me now, it probably wasn't at the time. The obvious correlation is the quality of the team leader.
Mm-hmm. Okay.
Which brings us to this undone ID. Of course, you can only undone if your team leader is competent. So you need, you need very competent team leaders. That's
and incredible discipline as well, I imagine.
But also like motivation. It's like making it fun.
So next one, how to balance tech debt with adding new features at the same time.
I mean, this is really like the big issue. So that's why I shared this example and Thibaut, but not only him. The idea was initially to say, okay, we're gonna spend less than an hour every day analyzing defects. I mean, that's already an investment, but it kind of slips into the overall work normally, like smoothly enough. That will create an understanding of the system that will like already increase the competence of the team. Because of course, what is amazing is when you look at defects and you learn from defects, and you get, again, the undone. Because typically in the Thibaut example, I actually spend, I think, every other day with him, like looking at his analysis. And Thibaut is very good, but also I bring 20 years of experience to that. So it was like fascinating conversations every time. So I think it probably like taught him some stuff, and he then shared it with the team. So that also increased the level of the team. So that's one idea. It's already like just investing in the confidence of the team, which probably means you will have less bugs in 9 months down the line. And then the other idea was we get an understanding of what would be great to do at the system level. One of the big instructions was don't overreact. So don't like try to learn one big change for every defect, or you're gonna like go crazy. So analyze a lot of defects, and when you start seeing a pattern, then yes, then you can say, okay, guys, we really need to invest one sprint in, I don't know, rebuilding the permission layer, because it's a mess, and we've got so many bugs in the permission layer. And then I think what is interesting is you get much more interesting negotiations with product or business. Potentially. I mean, doesn't make you a perfect negotiator either, but that's what we kind of observed is we had more better teams over time and better conversations on what to refactor, and then you can see the numbers did go down by a factor of 7. So yeah.
So you create the evidence to make the better choices at the end of the day, just by recurrence of defects and so on. Thank you. I guess it's the same question around prioritizing tech debt. It's what we just discussed. And the other question was rebuilding versus refactoring. And those were questions at the start, so that's what people came with. Any other thoughts on how do you get to rebuild versus refactor?
Yeah, good question. I mean, right now, and I think it's an interesting example, like the very, very big project I'm talking about. I mean, you're not going to rebuild the whole project. It's like 300 people over 5 years. So the interesting thing is when you decide to rewrite. So let's call refactor like small things, and that's basically more personal development discipline, and then rebuilding parts of the thing. So the rebuilding parts, it's interesting because they always take longer than expected and bring less value than expected. But they're also amazing learning opportunities for the person doing them. So the main idea we had on that big, or in that tech organization is you rebuild when you take ownership of something. It's basically one way to build ownership of a module is you basically spend time rebuilding parts of it. Because, and what is interesting is I'm kind of highlighting something. The key of our quality strategy at the end of all that was one of the keys was to try to create ownership. Because you can't even do Dantotsu, you can't analyze defects if there's no one owning the defects. So you need to look at the system and try to find owners everywhere. Of course, the more modular your system is, the better it is. The less modular it is, the more the owner complains. It's like, why am I owning this shared common that everybody is letting their dogs poo inside? Why am I the one having to take care of dog poo? And yeah, the answer is someone has to. So sorry, it's you. It's not a great one. But then you potentially what you can negotiate on very critical systems and say, okay, we will be rebuilding it. You lead the rebuild. You will own the system after that. And that's kind of. So basically, to answer the question, the decision to invest in rebuilding a thing is when it's the source of too many defects and you have a potential owner.
And rebuilding is not always going greenfield from scratch, right?
No. I mean, it's rebuilding one module, so it's not greenfield. It's like it's a headache for 3 months with impact everywhere and trying to get people to help you, etc.
I had the situation with rebuilding an entire system for compliance in the bank, and it had gone unattended and a mess for so long that they just wanted a clean one. And the idea is that actually what you want to address is the operational debt of letting that system go to the point that you have to create a brand new one because it's such a mess. And eventually we did refactor the system because it was a better approach for meeting some of the compliance requirements they had. But also, at the end of the day, a Java stack on top of a database is a Java stack on top of the database. So you may as well start with what you got, because at least you have coverage and you have less unknown, and you can bite the elephant one chunk at a time type thing. So that's what we did,
Sure.
and it did show actually all the challenges inside the organization that were actually toxic and creating that sort of tech debt. And we had to actually address the ways of working at the same time as making progress, which was actually quite an interesting learning as part of this experience. So
It makes me think of a lot of things. Yeah, it's interesting.
the operational, we talk about tech debt, but we will not talk as much about the operational debt that created it, and that's what needs to be solved. And often working from the existing allows you to address that.
And I think one of the big challenges is you can rebuild. I mean, refactor is nicer because you can do it blindly in a sense. To rebuild, the big issue is how many learnings do you have that make you confident that your new design is much better. And I guess that's where Dantotsu is helpful, because you think, if I've been looking at defects for 1 month, of course I have a better knowledge of the system and my design is probably going to be better. Like, it increases the chance of the rebuild being useful.
Actually, in my experience as well, I've seen that putting people that arrive in a team, newbies, into the support of the app, and effectively, trying to do Dantotsu on that, and of course I need support for it. It's the best way to learn an app, is through its failings and through fixing it. Anyway, next question. We have question from Fortune, I think, around, have you tried to use tools like CodeScene for tech debt yet?
Yeah, we do it for, but in a very different context, by the way. We use it more for legacy evaluation when we're talking about starting a big migration. Yeah, we've never used it for. It's interesting. We've never used it, for example, we never thought of using it on the big project, and it does. Actually, you know what? No, I know someone tried and they didn't find it useful, and I don't have the exact answer why they didn't find it so useful. But I guess when you're working on something, you have such deep knowledge already and deep intuitions of where things are wrong, that CodeScene, is making it a lot more beautiful, but it's not bringing you crazy insights. Whereas if you're looking at something you've never touched, then of course it's super interesting to kind of see where the issues are and see the dependencies. Yeah, for those who don't know, CodeScene is a great tool for doing like visuals of dependencies, and it's got these like scorings of where there's more mess and less mess. So it's quite nice, especially on a code base you've never touched.
And we're just on time, so maybe just the last question. Did the shift left that you mentioned include other roles in the process, e.g., product people, business analyst, etc., or just a developer? And an extension to this question is, how are you developing the team leaders as well?
So, all the crazy experiments we've done are really within tech teams, and it's annoying. It's probably why I'm like doing external communication, is to motivate other teams inside the organization. I would say, to think what would. So yeah, so the techies are the ones that are, I'd say, the most excited about these things today. Of course, we have a very strong problem-solving culture in every team. So the but not not inspired by Dantotsu ideas. How do we develop the team leader? It's a tough one. I think Dantotsu is an amazing way to develop the team leader by self-analyzing the defects. We have what we call an academy. So on some key things, and typically how to analyze a defect and the kind of standard we use to then share this analysis. There's a training for that. There's a training for problem solving. So we have these different things. But I think what really accelerates the training of the team leader is this introspection on defects. It's amazing. And of course, when they don't know how to answer them, and done to the person more experienced. So that's basically our strategy.
And yeah, I've seen that as well, that just the practice creates the culture at the system level, and the leaders, they emerge from that. And sometimes, you see also great leaders emerging from, some developers, and you see their potential as part of that.
Yeah, I mean, this is a really good point. I love how these kind of practices can highlight very shy people. They don't talk loud. You wouldn't think they have, leadership in the classical sense. And then you see them bring a problem-solving culture to their team, motivating the team to problem solve, helping them do it. And you start looking at the team, you're like, this team is weird. There's no problem. Everything's smooth. and it's this guy who never talks. Interesting. And yeah, so I love how it can highlight a different style of leadership that is actually incredibly valuable. And yeah, this is a very inspiring message.
Thank
do
you.
it just to highlight the shy but super competent people.
And that's probably the one we close up with then. Well, thank you ever so much for sharing that wisdom, all this wisdom with us. And for all of you, making your lunchtime to listen as well. We will put the recording out there, and please do socialize it with your leaders and the people in your teams, because that's how we spread that sort of culture of continuous improvement, which is often, I strongly believe that if we started the big transformation effort or attempts with small continuous improvements everywhere, and systematically from the defects, we would be in a better place with change. So please be the ambassadors of it, all of you. Thank you.
Amazing. Thank you very much.
Fabrice.
Thank you, Philippe.
Thank you all. Have a great weekend.